Oh, hello, Tweedledum and Tweedledee. What are you two up to today? The Nobel Peace Prize. What on earth did you win the Nobel Peace Prize for? Well, it seems kind of a negative reason to win it. And there's something wrong. That medal just doesn't look right. Oh, so they give you just a chunk of it. They took away a piece. So you've got 85%. Well, that's better than nothing, I guess. So which of you is going to keep it? Oh, really? Oh, so we have an argument already about who gets to keep. Stop it. Stop it. Stop it. Stop it. Okay, let's calm down. To solve this problem for you two, I'm going to use Egyptian fractions. Egyptian fractions are fractions that have 1 in the numerator. So these are the whole set of them. Now, I want you to choose one of those. Oh, you chose one very fast there. That's okay. It is good to choose the higher Egyptian fraction. So 1/2 is very, very good. But there's no need to fight over it, Tweedledee. Now, it's your turn to choose. You can choose any one that you want. Okay? So you're going to choose the 1/3. Good choice. Okay. Now, we're going to see if that's possible, because it's not entirely obvious this is possible. So we started with 85%. That's 17 over 20. Now we have to see if that's possible to, first of all, take your 1/2 from that. So minus 1/2, well, that's going to be equal to, let's make both denominators 20. So that's going to be minus 10/20, that's going to be equal to 7/20. And now, Tweedledee, we have to see if 7/20 minus 1/3, if that's going to end up to be something that is positive. Now we need a denominator that's going to work, maybe 60. So that's going to be 21 divided by 60 minus 20 divided by 60 is equal to 1/60, which is perfect. That's my commission for, just coincidentally, that's my commission for solving this problem for you two. What we've shown here is that 17 over 20 can be found by being greedy, by each time choosing the largest possible Egyptian fraction. Is this always going to be true for any integer, even integers more than 1? Well, this was proven by Fibonacci, that same man with the bunny rabbits who came up with the Fibonacci sequence. Let's have another example. So 2/7 is equal to 1/4 plus 1/28. But what happens if we decide we are only going to have odd Egyptian fractions? Well, this was a question that was asked by Ron Graham, and it turns out to be very, very tough to solve. So 2/7 is equal to, oh no, things get very ugly whenever we deal with just odd ones. This is an unsolved problem, and I never thought, but there might be a moral reason for studying these. It might help cure greediness. I never thought of that. Yeah, let's give you another sample. So this is 5 1/21 Tweedledee. Oh, bless you. Now it's time for you to experiment with adding and subtracting of fractions. Enjoy the game. I'm trying to fix Sam's innards. I need to add oil to this system. So here I've added the correct amount of oil because I've managed to get the ball bearing out. The amount of oil that I have to add is equal to the difference between the oil level here and the oil level of the first hole, plus the difference between this oil level and the second hole, plus the difference between this oil level and the third hole. So that is 2/6 plus 5/6, that's 7/6, plus 1/6, that's going to be 8/6. So I bring this up to 8/6 and I add 8/6 worth of oil, and that should solve the problem.
Good job.
This becomes more difficult whenever we have different denominators. So here, most of our denominators are 12, but one of them is 4. Here we have 1/4 over here, so the denominator is 4. How are we going to solve this? Well, we need to add 5/12 here, plus 2/12 here, that's 7/12, plus 7/8 9/12 over here. So 9/12 altogether. Let's go. Oh, what is 9/12? So now we have to think. I think it's 3/4. And we go like this, and we've been successful. Enjoy.